Hello guys, welcome to this lecture. And in this lecture we'll be starting with strings actually. Okay, so in this session we'll be seeing about the strings, and we will be seeing about character set. First of all, character set means ASCII code. About ASCII code already I think so we have seen, but again just let me brush up those concepts. So character set, ASCII code we'll be seeing, then followed by character array, then followed by about string generally, then we'll be seeing how to create a string, creating a string. Fine. So these are all the things that we will be covering up. Okay, so first of all we'll just come to character set or ASCII code. Okay, so we know very well that everything in computer is numbers. Okay, so coming to character set, or otherwise called as ASCII code, we can say that everything in computer is numbers. Okay, so what we since everything is in computer is a number, then where comes the character from? So what happens is uh, American Standard Code for Information Interchange, it is an organization, and this organization what they did is that they created symbols like A, B, C, D, English alphabets, or few more numbers. So they created symbols, and for each and every symbol they give a numeric code, because only numbers are available to us. Okay, since only numbers are available to us, numeric number code, okay, number codes are assigned to few symbols. I'll just tell you about few symbols. We'll come to know what is symbols also. Okay, so number codes are assigned to every symbols. And how many symbols they gave us that actually 128 symbols only they introduced. Who? ASCII organization, they introduced only 128 symbols they introduced. Okay, symbols. So 128 symbols means what they did is that they took numbers from 0 to 127, and they assigned 0 to 127 to those 128 symbols, starting from 0 up to 127. So now tell me, if I need to store a number called 0 to 127, how many bit I will be requiring? We will be finding it shortly. Okay, so 127, if I take, I have to first of all divide it by 2. If I divide it by 2, what will be my quotient? My quotient will be 63, and what will be my remainder? My remainder will be 1. Again divide 63 by 2. What will be my new quotient? 31. What will be my remainder? Remainder will be 1. Again divide 31 by 2. I'll be getting 15. And what will be my new remainder? My new remainder will be 1. Again divide 15 by 2. I will get 7. I will just get 7, and my new remainder will be equal to 1. Next one, divide 7 by 2. Divide 7 by 2. We get 3. And what will be my new remainder? My new remainder will be 1. Again divide 3 by 2. My new quotient will be 1, and my new remainder will be 1. Again divide 1 by 2. What will be my quotient? My quotient will be equal to 0, and my new remainder will be equal to 1. Once your quotient becomes 0, you can stop the process. I think this conversion process already I have taught you in the very first video, but again I have shown you. Okay, so how many reminders I have got? 1, 2, 3, 4, 5, 6, 7 reminder. It means that 127 is the largest number, and that largest number can be represented in actually 7 bit. So what is the maximum bit I require? The maximum bit I require is 7 bit. But you come to computer's very smallest memory block is itself 1 byte. The very smallest memory block is itself 1 byte, which constitute about 8 bits. So what happened is I will not be able to partially allocate only 7-bit. So what happened is that automatically they rounded it off and they allocated totally 8-bit. 8-bit means 1 byte. That is a reason why character always will take 1 byte of memory. So now we have proved that character variable will take only 1 byte of memory, because there are totally 128 1 byte, and there are totally 128 element, characters only available in ASCII, and those 128 characters are given the integer values from 0 to 127. So if I need to store 127, then I am requiring 7-bit only. So that is a maximum value also. So I can say that it requires only 7-bit, but computer's smallest memory block is itself 1 byte. So I will not be able to partially allocate 7-bit, so I am allocating 1 byte of memory. Okay, fine. So we will also just see about a few ASCII codes also. We will just first of all take, they have included only English alphabets. Okay, they have included only English alphabets. So let me introduce few English alphabets like A, B, C, and it is going to be up to Z, for example. Okay, so we'll just I'll just tell you about A. What is the new number assigned to A? A is given the number code called 65. B is given the number code called 66. Okay, 6 is given, the C is given the ASCII code of 67, and this goes on up to Z, and Z will be having the its uppercases. This is all uppercase characters. Okay, alphabet as well as uppercase. So it will go up to Z, which will, so continuously. Okay, 65, 66, 67. D will be having 68. So up to Z 90. These are the numbers allocated for English alphabets, that to uppercase. Coming to lowercase, small a will be is assigned with 97. Lowercase b is assigned with 98. Lowercase c is assigned with 99, and this keeps on going up to lowercase z, which is assigned with 122. Again, if you come here, if you see, among this 128 characters, even number also occurs as a character. Numbers also are changed into a symbol. So there exists a symbol called 0, and which is allocated with the numeric value 48. There exists a symbol called 1, which is assigned with 49. 2 is assigned with 50. So this keeps on going up to 9. Only digits we are having from 0 to 9, we are having it as a symbol. Okay, so 9 is assigned with 57, and this keeps on going. So if you see for space, even space is also having a, if you just give space means not the character space, not this word space. I'm just speaking about the space that you give using space bar. Whenever you give a space, that space is converted to a ASCII code 13. It is given a value called 13. Coming to enter, whenever you press your enter keyboard, in keyboard you have enter key, right? Whenever you press a enter key, it is converted to ASCII code called 10, which is also represented by a escape sequence called /n. So /n is having a corresponding ASCII code called 10. Then if you come for escape is also having a number called 27. So like this, you can keep on seeing all those 128, but these are the very important characters that you need to remember always. Okay, fine. So see, ASCII code is one way of character encoding only. Okay, so we have also, like, if you know Java is having a different encoding format. Here we are following ASCII code. There in Java we are following Unicode, which is completely different. It occupies 2 byte, and 2 byte in the sense the number of character is very vast there. Okay, it's 2 power 16 characters are there. because Unicode is made for all the languages like Chinese. A lot of languages are available here. Only ASCII code is having only English alphabets, English character symbols. Okay, fine. So we are not going to see about Unicode and all because we are seeing C. Okay, fine. So now I'll just declare few, I'll just show you few demo of characters, how to assign, how you should not assign, all those things we'll see. Okay, fine. So character.c, fine. Okay, first of all we'll just include the standard input output header file followed by the main function, manager function. Okay, so first of all, how to declare a variable in character data type. First of all, the type character followed by char followed by the variable name. For example, let me take ch. Okay, so this is declaration part. So this is called as declaration of a character. Fine. Now how to initialize? You can initialize in a separate line or as well as in the same declaration or line also you can initialize. Now I'll just initialize in the different lines. So ch is equal to single quote a. This is a valid initialization. I'll just tell you which is valid, which is invalid. This is a valid initialization. Okay, fine. So what I will do is I'll just simply print and I'll just show you. See, for character the corresponding format specifier is %c. Okay, so comma ch. So now what I will do is I'll just simply execute and I'll just show you. I'm just compiling it. Okay, compilation is successful. Just will go for execution. So in the execution phase, if you see, it is printing me a. So which means that this is a perfect way of declaration, initialization, and also we are doing the printing. I'll just show you the background process, the step-by-step background process, so that you may understood how this is stored in the background level. So one thing that I told you is that a character, there's nothing called character. It is having, see, if you see here, it is having a corresponding ASCII value called 65. So what will happen is that when you're compiling your code, automatically this a will be converted to 65. So let me execute this fifth line. If I just execute this fifth line, if you see, the variable is stored with actually integer, and that integer is having a alternate representation called a, which means that in the memory block character is not stored, only number is stored. The corresponding ASCII number is only stored. Okay, so now this is one important thing that you should understand. in the memory block, you don't store the symbols, you don't store the character symbols, you store the characters corresponding ASCII code only, which you need to be very clear about. Okay, fine. So one more thing that I need to show you here is you cannot do something like this. Two characters cannot be enclosed using single quote, as well as two characters cannot be stored in a character variable. Character means single symbol. It defines to single character. It means that it is single character or single symbol. Okay, symbol. So you cannot store multiple characters, or multiple symbols cannot be stored in a character variable. We have alternate technique to store collection of characters, but here in normal character variable you will not be able to store a collection of characters. So this is completely wrong. Okay, fine. So next, okay, so I told you that this is a valid one, this is a valid one, but this is not valid, this is not valid. See, always whenever a symbol is enclosed within a single quote, then only it is called as a character. Whenever a symbol is enclosed within a single quote, then only it is called as character. If it is not enclosed in single quote, then it is called as variable. Can you able to see here? This is also symbols, but these symbols are not enclosed by single quote. But so if it is not enclosed by single quote, it defines as, it is taken as a, considered as a variable. Okay, so you need to enclose it. If you enclose it, what will happen? It becomes a character. The way when the same symbols not enclosed within a single quote is referred to as variable, when it is enclosed within a single quote, then it refers to a character. Okay, so that one thing you should remember. And character cannot be enclosed within a double quote. Okay, it can be only enclosed within a single quote, so no double quotes are allowed. So this is a wrong way of initializing a character value to a variable, character variable. Okay, so I have to told you what is a valid way or invalid way of doing it. Okay, fine. So now what we will do is that the next concept, I think, hope now you understand about characters. Okay, see one thing, if you print it like percentage C, say this is the invalid way of initializing, so you have to go with single quote. Whenever you print with percentage C, the corresponding symbol will be printed. Suppose if you are printing it using a character can be also printed using percentage C, what will happen? A will not be printed, the corresponding ASCII value called 65 will be printed. It's a simple conversion. Okay, it's a simple conversion from symbol to number, from number to symbol. This is what called as encoding. So ASCII is one of the character encoding technique which you need to understand. Okay, fine. So now first thing is that about character set or ASCII code. I hope you'll be getting a good idea of it. And now we'll be entering into character array. Okay, character array. So I'll show you how to store the collection of characters. How? When we have 5 different integer, when those integers has to be grouped together, what we did actually for storing a collection of integer, what we did, we took a concept called array. Am I right? Similarly, if you want to store collection of character together, then you have to go with array, but this time you're storing character as array, so this is called as character array. So when you store integer as array, then it is called as integer array. So that's it. That's no new word called character array. The same arrays that we have already studied, but we are going to take that array, but inside array we will be storing the character variable, character value, not an integer. But if you see, characters are integers only. Okay, so both are going to be very similar only. Okay, so I'll just show you. So how to convert a normal character into a array by creating a bracket, square bracket like this after your variable name. Then inside this you have to specify a number which says that how many element generally, but how many characters you are going to store here in the character array. If I want to define what I need to enter inside this bracket, I need to say that total number of character. For example, let us plan to store something like programming. So how many characters will be there in programming actually? PROGRAMMING. So 1 2 3 4 5 6 7 8 9 10 11. So totally 11 character. So if you want 11 characters to store, just please declare 12. I'll just tell you why one extra space you need to take, that we will just discuss. But if you require 11 spaces, take 12. If you want 12, you take 13. If you want 20, take 21. Okay, fine. So now when it is coming to character array, then this is not the way of initializing it. How to do it? We know it already. So for example, I'll show you in this declaration part itself. We will not be able to do a different. See, if I want to do, I'll just first of all show you the same line initialization. In declaration line itself, we can able to initialize. So how to do it? Equal to parenthesis, sorry, yeah, curly braces, curly braces. This is how I think so. We also took in integer array also we took uh, curly braces only. So inside curly braces, what you have to do? You have to take first character like integer, first integer, comma, second integer, comma, third integer. Similarly, first character, comma, second character, comma, third character. So what we will do? P, second character is R, third character is O. Similarly, we will be just taking each and every character separately. Let me take this character one by one. So programming, okay, each and every character have been taken separately. Okay, fine. So now what we are going to just tell you is that, okay, all the characters have been just, so for example, how to access each and every character now, how to access each and every character, same index system will be used. Okay, same index system will be used. So where the index starts from, it starts from 0. I have already told you the reason in the previous videos why we are starting with from 0. Okay, you can go for that video and come again here. So if you are watching every video one by one, then you will understand why index starts from 0 and how to access each and every index. So for example, if I just want to print a character which is in third index, so 0 1 2 3. Okay, so I just want to print the character, not the ASCII code, so I'll just go with percentage C. We'll just check whether it is printing G or not. If it is printing G, then index system is perfectly suitable here for character array also, that we can conclude. Okay, it is not printing anything, it is not printing anything. What's the reason? We'll just check it out. Okay, so what I'll just do is that I'll just include one more character at the end followed by a null character. I'll just tell you why this null character is for. I'll just tell you why this is for, but before that we'll just check whether this is, no, this is also not printing it actually. Sorry guys, I have done a very silly mistake. I have not mentioned the index actually, so I'll just go with index 3. Okay, fine, sorry for the inconvenience. So just again I'll just go for compilation, I'll come for execution. Yes, perfectly, it is printing G, which means that the index system is perfectly working for the character array also. Now I'll tell you why the /0 coming at the last, to just show that this is the end of the array, end of the string. So why I'm calling it as a string? Because this is a character array. So character array only we are terming it as string. What is string? String is defined as the collection of characters. So collection of characters is what defined as a string. So collection of characters is what string. String is also called as character array. So we don't have a separate data type called string here, but we have character array, which is generally termed as string. We have only character array. This is character array. Character array is having another name which is called a string. We can generate, because what is character array? Collection of character. Collection of character is only called a string. So this is generally character of array in C, but generally it can be also called a string. Okay, fine. So now you can able to see that in the array, not the symbols are not stored. What is stored? Only the characters are stored. Can you able to see here? Only the numbers are stored. The corresponding numbers are stored. So I can just show you here in the execution here, background in the compiler also. Let me show you how this is working. So execution started. Activation area for main is created. Inside that you have a variable called ch block. 12 blocks are allocated. So if you see, everything is now garbage values. So I'll just execute line 5. If you see, only the ASCII values are stored. ASCII values are stored in the memory block. Okay, fine. So now for the null character, what is the corresponding ASCII value? 0. 0 refers to null character. Okay, I'll just tell you why this null character is for. See, there exists one more format specifier called percentage yes, specially made for this collection of characters. This percentage yes, what this percentage yes will do, this will start the reading process from the first character. This automatically runs like a loop. This percentage yes automatically runs like a loop, and it will read each and every character, P R O G R E. So it keeps on reading all the characters one by one. But what happened is that the developers want to stop this reading process at some point of time. See, you start from first character, 0th index character, and you keep on going to the next immediate blocks, and you are reading all the characters, subsequent characters. But what developer thought is that I need to have an ending point, okay, where this percentage s should stop. So where it should stop. So while they are thinking about that, they introduced a new character called null character, and they placed it as a they defined it as a end of a string. So until when this percentage s will be reading, until I find a /0. If I don't find a /0, it keeps on running. What will happen? Sometimes memory error will happen, sometimes unexpected string will be printed. So but some undetectable behavior will be happening, undetermined behavior will be happening. So now we will check by using percentage yes. Percentage yes means it's string, so don't specify any index here. Okay, so now what I will do is I'll just save it, and we will just execute this and check whether what is printing. We'll have a look at it. If you see, the entire string is printed at a stretch. This is what the power of percentage is. So you start from 0th index character, you keep on reading all the characters one by one, if you see, and I stop whenever I see a null character. Okay, fine. See, you can also give space, or you can also not give space whenever you are doing the initialization in the same line. I'm just talking about the initialization in the same line of declaration. When initialization and declaration are happening at the same line, you can also specify, and you can also skip it automatically. Your compiler will be allocating how many characters you are giving, that many characters. So now what we will do is we will just take this null character, and then we will just print and check what is now being printed. Okay, no issues. Okay, so whenever you are not providing the size, what will happen is automatically at the end a null character will be automatically given. When automatically /0 null character will be given, while you are writing a scanf statement, there also you have percentage yes. For example, scanf, and here also you are having something called as percentage yes, comma ampersand ch. For example, let me consider. So in scanf also you are having percentage. What this percentage c will do, percentage s will do, whenever you are doing percentage yes using percentage f, whenever you are using your scanf, it keeps on reading. Whenever you give an input, it keeps on reading until you get an interruption. What is interruption? Either space or a new line, both are called as interruption. I'll just show you one example of it, and then we will move it further. Okay, so now I'll just simply declare it with the size 20. Okay, I'm just going to enter the same programming, the word called programming only. Just first of all, I'll just declare it, compile it. Now I'll go for execution. It's waiting. So now what I will do is that I give p. Percentage yes is like a loop, so it keeps on reading. So let me give r. It reads. It reads programming. So whenever I keep on giving characters, it keep on reading. But if I give a space, the reading process stops, because this internal compiler is considering space and a new line as a interruption. So whenever interruption is coming, the scan that percentage yes will stop its iteration, and that particular position wherever interruption is happening, that place it will include a new line character. So in this place I have typed enter. So what will happen after G, it will be automatically, wherever I'm doing the interruption, that place it will automatically insert a null character. Okay, fine. So also I'll just give one more example, like using space also we will just do it. For example, C programming. So if you see, after C there is a space. After C there is a space, which I told you already that space is considered as a interruption. So what will happen? Only C will be read by the percentage yes format specifier, and whatever after space will not be read. Okay, we'll just check. You can able to see only C is printed because you have a space here. So whenever a space is coming, what will happen automatically? Automatically the reading process will stop. I can give you a longer one. So programming space programming C. Okay, now what has to happen? From P to G, programming will be successfully read, but once it sees space, it will stop. So C will not be read. So you can able to see that also here. So this is it about percentage yes, how to use, where to use, how this will be. So according to percentage yes in scanf will automatically place a null character by default. So you don't worry about it. Okay, fine. So what is the next thing that we need to see? Okay, so the next thing is that I have shown you one way of initializing it in the declaration part itself. So what can happen is that instead of giving a character, you can directly give numbers also. 65 comma 66 comma 67 68 69 70 71. Directly you can give number. Automatically these numbers are taken as a ASCII code, and whatever the corresponding symbol for this ASCII. What is the corresponding symbol for 65? Capital A, capital B, capital C, D, E, F, G. Automatically this encoding process will be taken care by the compiler itself using ASCII code technique. So you can directly access like this. What will be printed? A, B, C, D, E, F, G will be printed. So we can just check it. You can able to see here A, B, C, D, E, F, G. A corresponds to 65, B corresponds to 66, C corresponds to 67, D corresponds to 68, E is for 69, F is for 70, and G is for 71. Okay, okay, fine. Okay, so this is it for this session. So in the next session I'll just continue this. Okay, so I think the time is now I think we started the session by 10 and the session has already is been running for successfully for 30 minutes. So it's now literally 10:33 this is now. So what we can do is that we can do one more session by 10:45. Okay, so for one more half an hour we can do. So in that I'll just continue from here. Okay, I'll just continue from here. We will be continuing strings from where I just left. Okay, this is it for this session. Thank you.